Hello everyone. Hi, I am Fatima and today I want to talk about a problem that sounds simple on paper, auto logout, but gets surprisingly hard once you are operational at scale. This isn't about theoretical security models. This is about what actually works in a real SPA, like a single page application with millions of users, long lived sessions, and real production constraints. The real production constraints could be your servers are stateless instead of stateful, so you cannot maybe afford WebSockets to constantly interact with the server and stuff. But yeah, let's go and look how what was the problem and how we solved it. So the core problem was dormant session. User would go inactive, sessions would expire on server side, but the SPA would happily keep rendering as if the user was still authenticated. That's a security issue, especially when you're dealing with sensitive or cached data. We had to warn users before logout, handle multiple tabs, long lived sessions, and do all this under high traffic without having polling or sticky sessions. Sticky sessions are something where one session is just interacting with one server, and there's a dependency that the server won't change uh, till the session is alive. So we don't want that dependency as well. At high level, the architecture is intentionally boring, and that's a feature. So the client uh, is interacting with a Spring Boot API, which is a backend server API, which may interact with a session layer, and the session layer is getting the information about the session from a Redis session store. It gives the time left in current session to the client, and the client can then decide whether they want to show a warning or directly log the user out. And the warning interaction can also let the user give the opportunity to either extend the session or log out. And once logged out, our Spring Boot would expire the TTL in our Redis store and update the server information around the session. The logout behavior on the client side can be different for the guest user, maybe rendering a public page in a guest user context or moving them to a login page, maybe showing some warning that you're logged out due to inactivity. The entire system hinges on three timestamps. Last activity TS, updated only on meaningful activity. We don't want to update it on just like tab switch, or maybe when the client is logging some periodical logs for analytics and stuff. We want to have a proper timestamp when the user made the activity. The second one is the warning timestamp, when the UI should warn, and the TTL enforced by the Redis, not by us. Redis wasn't chosen because it's trendy. It was chosen because TTL is native, fast, and shared across instances. Once Redis expires the keys, the session is gone. No ambiguity, no cleanup jobs. The API surface is deliberately small. So the first API is activity heartbeat, which just tells the user is alive. The second one is session status, returns the status, not events. And then the session logout, which is idempotent. It behaves the same way every time we call it. Once the user is logged out, it is logged out. Then the API doesn't decide what to do, it just tells the client where in time the session is. This pattern is called time-based state machine. Now the warning time logic is pure math. No schedulers, no cron job. The 30-minute session warning at 25 minutes. Redis TTL is simply the expired TTL minus now. If Redis is up, the system works. If Redis is down, session fail closed. So there are two ways to close the session, fail the session. We can fail it open and fail it closed. Fail open means that the system behaves that the session is alive. Fail close is the system behaves that the session is not valid. So this is an architectural decision, but for now we can move towards session is closed for more security, secured website. Polling gets a bad reputation, but here it's a trade-off. Predictable load, easier than WebSocket at scale, works behind corporate firewalls, so we are protected from DOS attacks and injections and stuff. We don't poll constantly, polling only starts after activity crosses a threshold. So boring beats clever when millions of users are involved. Now let's look at the security consideration. A key rule: the browser never stores the session. No session data client side. Redis enforces the logout. Stateless APIs idempotent logout. Multi-tab safe. Even if one tab lies, Redis doesn't. Then scaling to millions. This design scales because it avoids per user work. No background jobs, O of 1 Redis operations, horizontal scaling. Some lessons learned were TTL, let Redis TTL do the work. Keep response minimum. Don't schedule what time can compute. Yeah. We tried a lot of things that looked simpler. In-memory storing of sessions on client side, but it breaks on scale. Heavy polling, again, it's a traffic issue and we don't want our backend servers to be overwhelmed. WebSockets, it is very much relied on the infrastructure and the reliability cost is high, and we wanted to give the flexibility that we could use serverless servers like AWS Lambda to host our sites. So if we use WebSockets, it won't be we won't be able to use serverless servers, stateless servers. Sorry. DB expiry, slow and operationally painful. So now the key takeaway, the big takeaway, designed around time, not events. Redis TTL is one of the most underused primitive in distributed systems. Security and UX don't have to fight if the architecture is honest about the trade-offs. Now I have some code snippets. You can definitely pause the video here and look at the code snippets more. I won't walk line by line here. The point is structure, not syntax. So I have a Redis config here, a TTL source of truth, and a stateless controller. There's no magic here, just disciplined boundaries around our logic. That's the system. Simple pieces carefully composed. Happy to take questions, especially about the edge cases, trade-offs we didn't cover. And thank you so much for staying with me till the end of the video. We'll be waiting for your comments. Thank you so much.